Hello, my name is Genesis Monroy Ribe. I'm a student at the Polytechnic University of Puerto Rico in Science 1441, Section 80. This is Laboratory 6, Kirchhoff's Laws, Electrical Circuit Analysis. This experiment focuses on applying Kirchhoff's current law, Kirchhoff's voltage law, and the superposition principle to analyze a circuit with multiple sources. I analyze an electrical circuit using Kirchhoff's current law, Kirchhoff's voltage law, and the superposition principle. KCL says that the sum of currents entering a node equals the sum of currents leaving that node. KVL says that the sum of voltage rises and drops around a closed loop equals 0, and the superposition principle allows us to study the effect of each source independently in a circuit with multiple sources. My hypothesis is that if Kirchhoff's laws and the superposition principle are applied correctly, then the calculated, simulated, and measured values will be similar. The objectives were to apply Kirchhoff's current law to a multi-loop circuit, apply Kirchhoff's voltage law to closed loops, analyze circuits with two voltage sources, use nodal analysis to find node voltage, and compare simulated, calculated, and measured results. To analyze the circuit, I use KCL, KVL, and Ohm's law. I also use nodal analysis to solve for the node voltage, which allows calculating the voltage drops and the branch currents. The methodology was divided into three parts. First, I built the circuit in simulation and recorded the voltage and currents. Second, I solved the circuit using nodal analysis and calculate currents and voltage theoretically. Third, I built the physical circuit and measured resistor values, source voltage, and branch voltage and currents. Here is the physical circuit built on a breadboard. I use a digital multimeter to measure voltage and currents in the circuit branches. During measurements, I paid attention to proper probing technique, since small contact resistance or loose connections can affect readings. In the simulation, I recreate the circuit and set the two voltage sources. Then I record the simulated voltage across each resistor and their currents in each branch, and I place them in the simulation results table. For the theoretical calculations, I applied nodal analysis to solve the node voltage, labeled as VA. After finding the node voltage, I determined the voltage drops across each resistor using the loop relationships, and then I computed the branch currents using Ohm's law by dividing voltage by resistance. The calculated results were recorded in the calculation table. In the measurement stage, I measured the actual resistors values using the multimeter, then confirmed the source voltage. After that, I measured the voltage and currents in each branch of the circuit and recorded them in the measure table. On screen, I am showing the simulation results, the calculated results, and the measured results. Here is an example of the computation process. I start with the nodal equation, solve for the node voltage, then compute each resistor voltage drop, and finally calculate a branch current using Ohm's law. This is the same process used to generate the full calculated table. In this analysis, I compared the simulated, calculated, and measured data. The simulated and calculated values show strong agreement, which supports that the nodal analysis and Kirchhoff's law were correctly applied. The measured values show slightly larger deviation, especially in current measurements, but they remain within an acceptable range. This difference can be explained by experimental uncertainties and component tolerance. Possible sources of error include limited instrument resolution, calibration conditions, probe contact resistance, and small variations in wiring connections. In addition, the internal resistance of instruments and possible instability of voltage sources can introduce systematic error, while connection fluctuations can cause random error. In conclusion, I successfully achieved the objectives of applying Kirchhoff's current law and Kirchhoff's voltage law to analyze a multi-source circuit using simulation, theoretical calculations, and experimental measurements helped me understand how voltage and current distribute through the network. Overall, the research supported my hypothesis that calculated, simulated, and measured values will be similar. Thank you for watching.